Hello. So the question is, we need to find if the parentheses are valid or not. So we are given a string which contains only these characters, and we have to determine if the input string is valid. Let's look at the constraints which are provided. The opening brackets must be closed by the same type of brackets. Okay, so it's saying that if this is present, then this should be there as well, and similarly for the others as well. Opening brackets must be closed in correct order. Okay, so cannot have something like this, I suppose. Let me check this. Mm, I think this means this. Okay. Every closed bracket has a corresponding open bracket of the same type. Okay, this is self-explanatory. Let's take this example. This is true. This is okay. Second point. Hmm. So let's do one thing that we can take a stack of contain the characters. So we'll take a stack of characters. Now let's iterate through the size of we are incrementing it one by one. Now we have to push it to the stack as well. Um, we have to push if it is an opening bracket. So if s dot character at ith index is this character, opening characters. Similarly for the others. If this is there, then we need to push it to the stack dot push. If it is anything else than the opening bracket, then we need to mm, get it from the stack. Character, let's say, for example, it could be T, but there can be a case that the stack is empty. So if the stack is empty, because we are peeking into the stack, right? So if it is empty, then it will this will return null pointer exception, right? So we need to check if it is empty or not. If it is empty, then this means that we have encountered a closing bracket before getting any opening bracket. So this should return false. Else, if it is not empty, we get the first, we get the element, we get the top of the stack, then we compare. So if t is equal to this and s dot character at I is equal to the closing bracket. If this is the case, else if, then all the cases, right? So we are taking all the three cases. So if we encounter a closing bracket and a subsequent opening bracket, then we can pop the element. Similarly for others, we need to change the brackets. If this all is there, then it needs to pop. If this is not the case, then we need to return false. Yeah, because the open bracket must be closed in the correct order, right? So if we are encountering if we are encountering something like if we are encountering something like this, we have the closing bracket, but when this is the character which is present in s dot character at I, and this is the stack which is present. This is the topmost element. So what happens is when we do stack dot peak, we are getting the square bracket closing one, but since this is not closing the curved bracket, so this will not be a valid case, hence we will return false. When we break out of this loop, um, if the stack is empty, then it should return true because all the checks have been done, and okay, yeah. See, what is happening here is all the checks are being applied on this logic, and then if after all of this the stack is empty, then it means that for the string the characters were in perfect order of opening and closing. So we went through the whole string, we pushed it to the stack, we checked if the stack is empty or not, we got the topmost element and then compared it with our um, s dot character at elements, and even after that if it pops and now if the stack is empty, then it will cannot find the symbol character. character at. We need to check if the characters are at this thing. Let's run it again. So the test cases, open test cases pass. Let's submit. Okay, it passes. Now let's check what is the time complexity and the space complexity for this. So the time complexity would be, since the loop is running only once, the worst case time complexity would be big O of n, that it needs to go through the entire, it will need to go through the entire string. So uh, time complexity would be big O of n, and the space complexity would be, it would also be big O of n, since let's say for example the stack is not in correct order, right? For this example, the the input is present, but the output is false. So what will happen is we'll push all the elements to the stack. It will take n positions, and then also it will not find the correct order of opening and closing. So it will return a false, and the space complexity would be big O of n as well. So yeah, thank you.